Hello everyone, I'm Akash. In this video, I'm going to solve one question on abstract algebra from IIT JAM 2018 exam. Question is, let G be a group satisfying the property that f from G to Z 221, that is cyclic group of order 221, is a homomorphism implies f of G equals to 0 for every G belongs to G. That is, if there exists a homomorphism from G to Z 221, then that homomorphism must be trivial homomorphism. Since every element of G maps to 0 element, that is identity element of Z221, such a mapping is called trivial map. So what is given? Given that there is only one homomorphism from G to Z221, which is trivial homomorphism, then the possible group G is, these are the options. There are two methods to solve this question. We will solve this question by both the methods. The first method is short trick. So let's solve the question. The number of group homomorphism from Zm to Zn is given by GCD of m comma n. So what is n here? N is 221. So replace n by 221 in the formula. We have to determine G here. So this is G. Okay. We have to find what is G here. We will determine the value of m from this formula, and so that we can select the correct option. Okay. So what is given? There is only one homomorphism from G to Z221. So this is 1. Number of group homomorphism from G to Z221 is 1, which is equals to GCD of m comma 221. Now we will determine the value of m from here. Now 221 can be written as 13 into 17. Okay. So clearly m cannot be 51, because if m equals to 51, then clearly we can see that 221 and 51 has a common factor 17. So GCD cannot be 1. Similarly, m cannot be 91, because 91 and 221 has a common factor 13. So GCD cannot be 1. M cannot be 119, because 119 and 221 has a common factor 17. So these three options are discarded. So we only left with option A. And clearly we can see that this implies m equals to 21, because GCD of 21 comma 221 is 1. So the given group G is Z21. Okay. Thus, so the answer is option A. This is the first method how to solve this question. Now let's solve this question with second method, which is a standard method to solve the question on homomorphism. But before that, let's recall what is homomorphism and what are its properties. If f from group G with respect to operation star to a group G dash with respect to operation hash is homomorphism, okay, then by definition of homomorphism we have f of A star B is equals to f of A hash f of B. This is operation in G and this is operation in hash. After separating the images, the operation is hash, because these elements belongs to G dash, whereas this element belongs to G. Okay. Now, if both G and G dash are finite groups, and let A belongs to G such that order of A equals to K, order of A equals to K, then by definition of order of element we have K is the least positive integer such that A star and so on star A equals to identity in G, e.g., because A is an element in G and A has order K, so K is the least positive integer such that A star A K times is identity in G. As both the groups are G and Z221 are additive groups, so we will also use the additive group notation. In additive group notation, A star and so on A can be written as K times A. So k times a is identity in G. Now operate f on both sides. F of k times a is equals to f of Eg, identity in G. And this implies, by properties of homomorphism, we know that this can be written as k times f of a. And what is f of identity element in G? Under homomorphism, identity element of this group maps to identity element of this group. So this is identity element in G dash. So Eg dash. So uh, for f of a belongs to G dash, we have k times f of a equals to identity element in G dash. And this implies order of f of a divides k. Since we know that if G is a group and B belongs to G such that M times B equals to identity, then this implies order of B divides M. Okay, order of B divides M. So here M times B equals to identity, so order of B divides M. Okay, so from here we see that order of f of a divides, what is k? K is order of a. Order of a. So we see that order of image of element divides order of element. So this is the property which we require to solve this question with second method. Okay, we'll use this property, that is order of image of element divides order of element, to solve this question with second method. Now let f from Z21 to, we have taken G equals to Z21 to Z221 be homomorphism. We will determine what are the homomorphism from Z21 to Z221. Here operation is addition modulo 21 and here operation is addition modulo 221. Now we will determine the image of 1. Since 1 belongs to Z21, then by theory that we have seen here, we have order of f of 1, that is image of 1, divides order of 1. Okay, order of image of 1 divides order of 1. What is image of 1? That is f of 1. F of 1 belongs to Z220 as f of 1, but f of 1 belongs to Z221, and we know that order of element divides order of group. Order of elements divides order of group. So what are the possible orders of f of 1? Since 221 is equals to 1 times 13 times 17. So possible divisors of 221 are 1, 13, 17 and 221. And since order of element divides order of group, so possible orders of this element can be 1, 13, 17 and 221. So this implies possible orders of f of 1 are f of 1 are 1, 13, 17 and 221. Okay, these are the possible orders of f of 1. But order of f of 1 divides order of 1. But order of f of 1 divides order of 1. 1 belongs to Z21 and we know that 1 belongs to Z21 has order 21 because it is a generator. 1 belongs to Z21 is a generator of cyclic group Z21. So it has order 21. So order of f of 1 divides 21 and possible orders of f of 1 are this. So we can clearly see that 13 does not divide 21, 17 does not divide 21, 221 does not divide 21. So only possibility left is 1. So this implies order of f of 1 is 1. But we know that only element of order 1 in a group is identity. And as f of 1 belongs to Z221, so f of 1 is 0 because 0 belongs to Z221 is an identity and it has order 1. So we see that the 1 belongs to Z21 maps to the 0 element of 221. 1 belongs to Z21 maps to the 0 element of Z221. Now we will determine the images of other elements. Okay. Now also 2 belongs to Z21 because Z21 is a set 0, 1, 2 and so on 20. Okay, and operation is addition modulo 21. So now we have determined the image of 0 is 0 because identity element maps to identity element. Image of 1 is we have seen that image of 1 is 0. Now we will determine the image of 2. What is image of 2? Now f of 2 is equals to f of 1 addition modulo 21 1 because 2 belongs to Z21 and we know that 2 belongs to Z21 can be written as 1 addition modulo 21 1. Now by properties of homomorphism, this is f of 1. After separating images, the operation will be operation of codomain. What is operation of codomain? Addition modulo 221. Here operation is addition modulo 21, but after separating the images, operation is operation of codomain, that is addition modulo 221. So what is this? F of 1 is 0. Addition modulo 221. F of 1 is 0, which is again 0. So we see that f of 2 is 0. So 2 maps to 0. Similarly, you can show that 3 maps to 0 and so on. All the elements of Z21 maps to 0. All the elements of G maps to 0. So we see that the homomorphism F here from Z21 to Z221 is trivial homomorphism. So if there exists any homomorphism from Z21 to Z221, then that homomorphism must be trivial homomorphism. That is, that homomorphism satisfies this condition. So answer is option A. Okay. So we have solved this question with both the methods. The second method is standard one and the first method is short trick, which consume very less amount of time. Okay. So thank you for watching.